they're promising they're releasing critical patch updates, you know, for the next 3 months coming, for the next year, then that says to me, my software is critically insecure. So I think that's a marketing own goal there. They should not be, they need to think about it differently as far as I'm concerned. DB2, I performed an assessment on that in about January 2005. You know, spoke to IBM about 10 floors or so. A couple of my colleagues at NGS Software in December 2003 did Sybase, literally did Sybase. They published about 50 floors and worked with Sybase to get those fixed. That was Mark, Sharif, and Rob. So SQL Server, when it was first released, had 1 billion floors in there. Oracle had 1 billion floors. DB2 had 1 billion floors. Sybase had 1 billion floors. Excuse the hyperbole. You know, there's a bit of a difference between 50 and 1 billion, of course. But suffice to say that this software, when it came out, was riddled with holes. So should Infomix be any different? Should we expect anything better? And of course, there wouldn't be much of a talk if they were like ultra secure. So let's talk about Infomix. What is it? Infomix is just another relational database management system. It was acquired by IBM in 2001. In the early 1990s, it was actually the second most popular database server out there, which is quite interesting given that it's not so popular these days. Current supported versions are 10.0.xc5 and 9.4.xc8. Now, what do I mean by that X? Well, let's look at version numbers just quickly so I can explain this. So it starts with a major .min, that's the number, like 9.40 or 10.0. If you see, when you're doing an assessment, let's say on an Infomix box, an FC, then you know you're on a 64-bit platform. If you see a UC, you are running on IRIX, Linux, Solaris, or AIX. If you see TC, you're on Windows, and if you're on HC, you've got an HPUX box. If you see TL, it says you're on a time-limited trial version, and RXN, where, you know, X is a number, is a release candidate, so like a debug build. So that's how you can fingerprint what, you know, what OS the Infomix server is running on. Let's talk about Infomix authentication. Uses operating system accounts, very much like DB2. You don't have database logins itself. The default user, when you install Infomix, is called Infomix, and depending upon the version, most of them will give you a default password of Infomix itself unless you change that. On Windows XP, if we don't have an account, let's say Infomix Dynamic Server is running on a Windows XP box. If we don't have an account on that box and simple file sharing is enabled, remember this is XP I'm talking about, then if we log on with a non-valid username, i.e. a username that doesn't exist, we can gain access to the system. And the reason is because simple file sharing is being enabled. And when you pass the username to log on user, you know, Windows logs you on as the guest user basically, and you know, returns a token. So as far as Infomix is concerned, you must have had a user ID and password and you logged onto the system. There is a buffer overflow in the authentication process. By presenting an overly long username of 260 bytes or more, you can basically overwrite the save return address on the stack and execute arbitrary code. We'll see that in the demonstration shortly. Now, IBM fixed that. And in fixing that, they introduced another buffer overflow vulnerability. What they do is they say, if the username is now longer than 32 characters, log an error. And in logging that error, they pass the username that was supplied to a call to vsprintf with a fixed size buffer of 960 bytes on the stack. So even their fix could be exploited to gain control. So currently, 9.40.x.c8 is still vulnerable to that, but you can go to IBM and get an interim patch before they release C9. 10.0.xc5 prevents this flaw. And the CV numbers that have been assigned are 3853 and 3854 for those two specific flaws. When you attempt to authenticate, the user ID and password is sent across the wire in clear text. So anyone who's able to sniff on the network or at least have a shell or some ability to gain, capture that traffic, then you can start picking off user IDs and passwords. You can prevent that with a communication support module. There are two of these. One is a simple password CSM and one's an encryption CSM. The first one, you obviously encrypts the password as it goes across the wire. The second one encrypts the data. Another thing about passwords, which I haven't mentioned in the slides, is the clear text passwords are stored in a shared memory segment in the process, basically. Now, if we can get the Infomix server to core dump, which we can do, as we'll see later on, then that shared memory segment is dumped into a wild-readable log file. So we just grep through that for people's clear text passwords. On Windows, the shared memory segment, everybody can open the section, basically, so we can just read directly from the virtual address space of the on-init process. So there's a number of password exposure issues there. If you analyze the protocol, once you've authenticated, the second byte of the next packet becomes an index into a function table, basically, and that determines what goes on next. There's a whole range of buffer overflows. For example, the remview SQL stuff, remproc, remove permissions, and so on. The list is on that side of the room. There's no point in me reading through it because there's lots of them. Suffice to say that all of them call the getName function. The getName function basically takes a source string and copies it to a destination buffer, very much like the strcpy function in C, essentially. So wherever they call getName, you're guaranteed pretty much to have a straight stack overflow. Or even a heap overflow as well, if they're using the heap. There are two unhandled null pointer exception flaws at the protocol level in the scroll and the bbind functions. So anyway, let's say forget those protocol attacks. Once you're connected, let's say what we'll see in the demonstration is actually we'll exploit the buffer overflow vulnerability to create an operating system account on the server. Once we've got that operating system account, we can then authenticate to the Infomix server. By default, public has the connect authority. The connect authority means basically that the user has the requisite permissions to connect to the server. So because public has this authority, it means anyone with an operating system account can connect to the database services. Now, once they've done that, there is nothing to stop you from saying, create database by default. So if we create our own database, once we've connected as a low privilege user, we then become the owner of that database, and as the owner, we're the DBA, and as the DBA, we can run code as the Infomix user, and as the Infomix user can trivially gain root on a Linux environment, we become root. And on a Windows environment, Infomix is an administrator, so we get admin privileges, and from there it's trivial to get system. So we'll look at that as well. Accessing the file system. How are we doing for time? Good, yeah. Accessing the file system. We can read files from the server using straight SQL. The way we do this is create a temporary table with a clob. A clob is basically a large object. We then use the file to clob SQL function to read whatever file we want to read from the server and dump it into the temporary table we've created. And then lastly, we create we use the load to file function to dump that text from the table onto the client system. So we can read any file we want as long as the Infomix user has the privileges to read that file. We can write files to the server. One of the things we'll be doing later on is basically creating our own DLL, dumping onto the remote server, dumping it into a table, flushing that from the table onto the disk, and then loading that library to execute arbitrary code. So again, we go through the similar functions to write files to the server. If we want to prevent access to the file system in this respect, you want to revoke the execute authority on the file to clob, load to file, and IFX file to file functions. There's an interesting SQL command called setDebug file, and I mean interesting because it's a fertile ground for bugs basically. So firstly, we can create output files on the server and write text to that file. The way in which that file is created on the server is with a call to system, basically. So we can inject operating system commands into the create file, into the set debug file command. We can inject operating system commands in there, and they run as the operating system, as the Infomix user. So anyone can come along and type set debug file to inject arbitrary command and have that run as the Infomix user. Funnily enough, the set debug file is vulnerable to a buffer overflow vulnerability as well. So there are 3 different attack vectors just with that one SQL command alone. And what's more, there's not a lot you can do to prevent someone from running set debug file. We spoke about loading arbitrary libraries just briefly. What we can do is using the ifx load internal SQL function, which public has the execute permission on, we can basically say, load this arbitrary library for us. On a Windows system, that will follow a UNC path. But as it happens, we don't need to follow a UNC path because we can write a DLL to the disk anyway, remotely. So what we would do in an attack situation is put the code in the DLL main function on a Windows environment or on a Linux environment in the init function. So that way, when the library is loaded by the Infomix process, the code will automatically execute. We can protect against this by revoking execute authority from public, of course, on that ifx load internal SQL function. So before I start the demonstration, are there any questions on that stuff? Nope. Oh, yep, sure. I do. CD dev CD. So I'm going to push out these advisories tomorrow, and some of these advisories, like, well, there's A2I there, and some of them, fix, like, talk about the fixes for 8 issues and so on. I'll get you the exact number shortly. But I think it's about 20 or so bugs, different bugs. But as I said, I'll get you the exact number shortly. Okay, so if you want to see the demonstration stuff, if you want to come over this side of the room. Yep.
How many daily servers will rely on running in Formix versus things like SQL Server or any feeling of that?
I don't know where Infomix appears in the whole range of thing, but probably less than 1%. Oracle probably has between 30 to 40%. DB2 has about 30%. SQL Server, I think, has about 15%. Sybase has about 3%. Teradata, I think, has about 3%. The NCR Teradata database has that. So, but that's excuse me, that's commercial, not necessarily MySQL, or open source stuff. Sure. Oh, wonderful. IBM are really responsive. They very communicative as well, and keep you informed all the way along. And what's more, they understand that you're just trying to help secure their product. If only people like Oracle would understand that, then we could all, stop the bitching and just get on with fixing,